All right, so here we go. This is number 68 from the Halliday and Resnick book, number 68 from chapter 4 of the Halliday and Resnick book. So we've got a cat riding a merry-go-round turning with a uniform circular motion. And here's what it tells us. It tells us that at time 1 equals 2.00 seconds, the velocity has a horizontal velocity of 3 meters a second and a vertical velocity of 4 meters a second, which means the overall velocity is going to be 5 meters a second. And then it tells us that at some time later, at t2 equals 5 seconds, the velocity at that instant is going to have a horizontal velocity of negative 3 meters a second and a vertical velocity of negative 4 meters a second. So your overall velocity is going to be 5 meters a second this way. All right. Now, all of this pertains to a cat going around on a merry-go-round in uniform circular motion. So the cat's going to have this sort of circular path, but it kind of doesn't tell us whether the merry-go-round is going clockwise or counterclockwise, which should lead you to believe that either there's enough information here for you to figure it out, which there isn't, or that it doesn't matter, which turns out to be the case. So I'm going to not worry about that too much, and let's just see if we can solve this thing. All right. So part A says to find the cat's centripetal acceleration. So what do we got to do here? So to find the acceleration, that's going to be v squared over r. So I know my velocity is just going to be 5, or I guess I should say my speed is going to be 5, right? Because that's just the hypotenuses of these two triangles. But we've got to find our radius, okay? So to do that, we got to think a little bit. So here's what I notice. These two velocity vectors, they're anti-parallel, right? They both point, they're parallel, but one of them points forward and one of them points backwards. So regardless of which way the merry-go-round is going, you know, maybe it's here after 2 seconds and here after 5 seconds, because those two vectors are anti-parallel, that means that the merry-go-round has gone halfway around. So in the time that elapses between 2 seconds and 5 seconds, we've gone halfway around. So 3 seconds is half of our period, so that tells us that our period must be 6 seconds. Aha! So that means that we can find our radius, right? Because I know that velocity is 2 pi r over the period, right? So we know our velocity is 5 meters a second. That's got to equal 2 times pi times my radius, which is what I'm looking for, divided by 6 seconds, right? So do the math, and you will figure out that the radius there turns out to be, where did I write it down? 4.77 meters. Okay, and so now we can plug that into our equation up here, 4.77 meters, and find our acceleration, which does, in fact, turn out to be 5.42 meters per second squared. Okay, so that's part A. Okay. Let's clear up some space here. Oops. All right, so there we go. All right, so the next thing we need to do, part B, is to find the average acceleration. So let's get a little bit more space here. Okay, so here we go. So for part B, we're trying to find average acceleration. This one is literally just plug and chug. Acceleration, average, is by definition final velocity minus initial velocity divided by time. Or for us, maybe I should write v2 minus v1, oops, over the time, right? Look, we've got two velocity vectors and the time between them, right? So I need to figure out the difference between my two velocities. So v2 minus v1 is going to be, well, I'm just going to write down my two vectors. So it's negative 3 I minus 4j, right? That's my v2, minus, I'm being sloppy about my significant digits again, 3i plus 4j, and subtract it. And what are we going to get? Let's see, we're going to get negative 3i minus 3i is going to give us negative 6i. And then negative 4j minus 4j is going to give us negative 8j. So there's my v2 minus v1, right? So I'll do this again. So I'm going to take my v2 minus v1 that I just found and plug it in over here, right? So I'm going to get negative 6i minus 8j. This is all meters per second, and we still have 3 significant digits. And then divide by our time. Well, how much time went by? Let's see. We went from 2 to 5 seconds, so that's 3 seconds, right? So you're going to get negative 2i minus, so that was 6 divided by 3 gave us the negative 2, and then negative 8 divided by 3 gives us negative 2.67 j. That's all meters per second squared. So there's our average acceleration in unit vector notation. And then finally, we just, put it back together using Pythagorean theorem. So let's see, we've got an x component of negative 2.00 meters per second squared. We've got a y component of, sorry, the board's getting cluttered here. We've got to find our hypotenuse. So do your Pythagorean theorem and you get your answer. All right, here we go.